Following on from the previous video, we were trying to look at an alternative way of integrating an inverse. So our old way of doing it would be to do this. So this is our old method. And then we would blindly follow this, and then put this into here, put this into here, and so on. Our old way of doing it, when we integrate it, it would then give us this. This is our old way of doing it. So the alternative way would be to do this. So if we're trying to integrate an inverse, the alternative way is to start out by saying let y equals this. So you can, because this is an inverse, you can easily say y equals this thing here. So for example, if you're trying to integrate an inverse tan, you start out with this. You start out with y equals this thing here. So because it's an inverse, you can easily say this: tan of y equals x. So if you start out with let's say natural log of x, then you would start out by saying y equals natural log of x. Because this is an inverse, you can actually say e y equals x. So when you're trying to integrate an inverse, you can easily jump from here to here because it's an inverse. So here's an alternative way of doing it. You start out with this. You start out by saying y equals this. Because it's an inverse, you can easily jump to here. Okay, so once you're here, from our section on differentials, we can jump from here to here. So that will then give us this. So you integrating this is the same as you doing this. Okay, notice that everything, because once you get to this stage here, dx equals this thing here. So now you can substitute this into the dx here, and we said let y equals this thing here. So you can put the y into this whole thing here. Okay, so if this y here is really this bit here, and then this dx here is really this whole thing here, which is this whole thing here. Okay, so from here we are able to work everything in terms of y dy. Okay, we are able to work everything in terms of y. So now we can just integrate it. So now use integration by parts on this bit. So now using integration by parts, it will then give you this. Okay, so because this is quite straightforward, this bit here, learn to train yourself to be able to jump from here straight to here. Okay, and then now integrate this. So that would then give you this. Well, overall, this whole thing here equals this. So remember, we said earlier, let y equals this. So this is our final answer, but everything is in terms of y. So now put this into here. Put this into here, and don't forget, So put it into here, and then everything, this whole thing here, will then become this. Because hang on, if you look at this here, cos of y. If you put this into if you put this into just the y here, this bit here, you've got cos of y. What you've got here is this thing here, cos of y. But remember, y equals this thing here, so we can actually say cos of inverse cos of x. So here you've got cos and an inverse, so that will leave you with x. So this block here is really just x, because when you put this into the y here, you're causing an inverse, of course. So this whole block here is x, and then the y, we can put this into the y here. So this bit here will be x inverse cos of x. So this bit here is this y here, and this block here is just the x here. Okay, so this whole thing here will then become this. So now here you've got sine of y, so you can actually put this into here. So this sine here is this bit here, and then the y is this whole bit here. So this here is our is our answer here. Okay, it looks kind of ugly because you've got sine of an inverse cos of x here, but it is a legitimate answer. So our first method, our normal method of doing this would be would yield this. Our new method, our alternative method, would yield this. The thing is that this here is exactly the same as this, but just written differently. These two are exactly the same. For you to understand why, let's look at this. This here is exactly the same as this, and here's why. If you look at this here, so back to our high school trigonometry, if you want to know the angle here, cos would be A over B. Cos would be A over B. So here, from here, you would inverse cos equally to both sides. That would then give you this. The point I'm trying to make here is that this bit here, the inverse bit here, you can think of it as being an angle. So this bit here, you can think of this as being an angle. This here, you can think of this here as being an angle. The whole block as being an angle. Because if you start out with this, inverse cos equally to both sides, that will then give you this. Now this whole block here is an angle. Think of it as an angle. So hang on. So when you look at this here, inverse cos of x, so this is what we've got here. We've got the inverse cos of x here. So you can imagine inverse cos of x as being like this. You can imagine inverse cos of x as being like this. This whole block here is an angle. This whole block here is an angle. Well, it's an angle of length x and the hypotenuse of 1. That's what x is, because this angle here is really x over 1. So if you want to know the angle, you would inverse cos of this. So, well, this here collapses down to x. So that would then just give you x. But you can imagine inverse cos of x as being an angle here. So this is your angle here. Okay. So if this is your angle, hang on, bear with me. If this here is your angle, then this is x and this is 1. So what is this length here? Well, this length here, by using Pythagoras, it would be square root of 1 minus well, it would be this. This length here is this. So when you imagine this to be an angle, then when you imagine this as being an angle, then this length here would be x. The hypotenuse here is 1. So this length here has no choice but to be 1 minus x squared. So this whole thing here, remember, sine, if you look at this, bear with me, it will make sense later. So here you've got sine of an angle in effect. So here you've got sine of this angle here. Sine of this thing here would be this. Sine this here. Imagine this as being an angle. Imagine this as being an angle. So this is your angle here. So when you sine the angle, it would be this. It would be this length over the hypotenuse. Well, what is this length? This length here is square root of blah 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 here. It would be this. So this whole thing here is really this length divided by 1. So it would be that. So this whole thing here is simply the square root of 1 minus x squared. So that's pretty much the same as our first method here. Okay.